Thank you for watching this video as a presentation for our work entitled A Bottom-up Approach for Feature Model Extraction from Business Process Model. So, in this presentation, I will begin by introducing the context of our work. Then, I will cite some existing works in relation with our objectives. Besides, I will present our approach, and finally, I will conclude with a summary of our work. So let's begin by the introduction. So let's introduce the concept of software reuse. What is software reuse? Software reuse means implementing new software systems, reusing existing software resources, rather than developing the same software capabilities again. So, the concept of software reuse is related to the concept of software product lines in most cases or in many cases. So, what is a software product line? A software product line is a set of software intensive systems sharing a common managed set of features that satisfy the specific needs of a particular market segment or mission and are developed from a common set of core assets in a prescribed way. So software flexibility means implementing, allowing to adapt the systems to the different customers of a whole market segments. In this context, software product lines focus on the commonality and variability to build a set of software products, while service-oriented architectures allow to compose, orchestrate, and maintain solutions based on services implementing business processes. So, what are the software product variants? They are similar software which share some features called common features and differ in others called optional features. Usually, an existing product is copied and later modified to meet incremental demands of customers. So what is a feature and what is feature model? So the feature is a system property which is relevant to some stakeholders used to capture commonality and variabilities among systems in a family. A feature model is a tree-like graph of features and relationships among them. So feature models in software product line engineering are used to represent commonality and variability of software product line numbers at different levels of abstraction. So the construction of software product line is a complex task since it involves the extraction of reusable components and the extraction of relevant information from assets to build feature models. So these assets may be whether products textual descriptions, like for example the design, functional and non-functional requirements, or source code of product variants. Given the wide coverage of an SPL, its development is more difficult than the development of a single application. Therefore, it is important to help the domain experts in building complete software product lines. So now let's move to present some existing works. For example, we find the work of Al-Subayhin et al., which investigate different techniques to compute the similarity of applications based on their textual descriptions and evaluate their effectiveness using hierarchical agglomerative clustering. We found also the work of Wesley et al., which consists in developing software product lines from existing system variants. So it accepts as inputs UML class diagrams and the list of features they implement in order to extract feature model and a product line architecture, which represents a global structure of the variants, etc., added to many other works. So now let's move to presenting the steps of our approach. So, why we decided to combine software product lines and service-oriented architecture? So, we decided to combine them in order to transfer the advantages from the software product lines to SOA, namely the business process model, in order to allow to adapt the systems to the different customers of a whole market segment, by starting from a deep analysis of business processes, identifying in them commonality and variability in order to build feature models. So the general objective of our approach is to extract initial feature model from similar business process assets. So our approach is composed of three main steps. The first step is the commonalities and variability identification. In this step, we use the FCA method in order to extract the commonalities and the variabilities among the features. So FCA stands for Formal Concept Analysis method. So the main idea of FCA is to analyze data described through the relationships among a particular set of data elements. So in our approach, the data description is represented through a table where the business process model variants constitute the rows, while elements of every business process model constitute the columns of the FCA graph table. From the table, a concept lattice is derived. From this lattice, we deduce firstly common elements, which are common block, which are commonly used in our products, and secondly, the blocks of variations only appear in specific products. Common blocks and block variations are composed of atomic blocks of variation representing only one feature. So the second step consists of the features identification. So besides the blocks, the lattice also indicates the relationships among elements, namely mandatory features which appear in the top of the lattice. So these are mandatory features. The others are considered as optional. Okay, added to the constraints XOR and require. So to define the similarity between the features names, we apply the latent semantic indexing method and the DBSCAN algorithm. So the last step is the feature model construction and constraints identification. In this step, the semantic information is used first to define the hierarchy in the feature model, and secondly to extract the types of constraints among identified features. For this, a set of semantic criteria are used to ensure that all the constraints among the features are extracted correctly, namely the synonymy, the hypernymy, and the meronymy relationships. At the end of this step, all the features are collected and all the features and the constraints are collected in order to build the final feature model. So we implemented our approach through our tool called FMRT, which stands for Feature Model Recovery from Business Process Model Tool. So this tool has namely the following functionalities: applying the FCA method, applying the LSI and the DBSCAN in order to define the common blocks of atomic blocks of variations, applying the rules to define the constraints between the features, and build or construct the feature model. So now we move to the conclusion. So this work presented a new original approach and its tool for extracting feature models from business process models. Firstly, it takes these business process models and constructs the FCA cross table. This table is used to extract the lattice from which we identify the commonalities and variations among all products. Secondly, this same lattice is used to identify atomic blocks, which represent the features by exploiting the semantics among them based on the LSI and the DBSCAN methods. And finally, the obtained features are grouped to build the hierarchy of the feature model and include the involved constraints based on semantic criteria. As a future work, we plan to enrich the synthesized feature models with features descriptions based on the textual descriptions of the activities involved in the input business process models. Also, we plan to extract the SPL design like the whole SPL class diagram. Thank you very much.